Good day, everyone. You are welcome to my YouTube channel, Mathematics Made Easy. In today's video, we'll be looking into one question involving the Fourier series. Okay, here's the question. It said, obtain the Fourier series for x squared over the interval minus pi less than x less than pi. And after that, we are to deduce that summation of n from 1 to infinity of 1 over n raised to the power of 4 is equal to pi raised to the power of 4 over 90. Okay, let's start the solution. Okay, now if we want to solve this question, we want to firstly obtain or derive the Fourier series for the given function, okay, which is s squared and over the given interval from minus pi to pi. Okay, so the first thing I'm going to do is to write down the formula for the Fourier series. So we have function x is equal to, so I'm writing the formula for the Fourier series. That's a naught over 2, okay, plus then summation of n, the n. So summation of n is from 1 to infinity. From 1 to infinity. Okay. Then so we have an multiplied by cos nx. Then plus bn multiplied by the sine nx. Okay, so that's the formula for the Fourier series. Okay, now from this question, the given function is x squared, that is f of x is equal to x squared. So that's the given function there. So f of x is equal to x squared. So then after that, let me write some formulas that we will need in solving this question. So your a naught is calculated using this formula. So a naught is equal to 1 over L, then integral running from a to b, then of f of x dx. That's the formula for calculating a naught. Then formula for calculating a n, that one is given by, so 1 over L, so we still have 1 over L there, then integral, so integral, so that one is also from a to b, of f of x cos nx, f of x cos nx, then dx. So that's the formula for calculating an. All right, and then we have the formula for calculating bn. So bn, that one is calculated using this formula. It's equal to 1 over L. So integral from a to b, of f of x sine x, f of x sine nx dx. So we'll be needing that formulas in solving the question. Okay, how are we going to solve for our L? So this is what we are going to do if we have to solve for our L. So L is just equal to b minus a over 2. So that's b and that a is from the given interval. Okay, b minus a over time of sorry. Okay, it's from the given interval. So our b, that one is pi, you know. So our b is pi, and then our a is minus pi. So b is pi, so that will be minus pi. Okay, so this is just going to give us 2 pi over 2. So it's going to give us 2 pi over 2. And then don't forget, if you divide through by 2, you can see 2 is going to cancel 2. Then what we are left with is just pi. So our L in this question is pi. Alright. Now the next step we are going to take here is to solve for our A naught. So that's the first thing we have to do. So solving for A naught. So we already have the formula for calculating A naught. So I already gave us that. That is A naught is equal to 1 over L integral from A to B of f of x dx. Integral from A to B of f of x dx. So that is the formula for calculating A naught. And then don't forget that our f of x is x squared and our L is pi. So we are going to have 1 over pi integral, our a is minus pi, so it's running from minus pi to pi, and our b is pi, so it's running from minus pi to pi. Then our f of x is x squared, then dx. All right, so this one is very easy. It's just a basic integral. If you integrate x raised to the power of 2, you're going to get x raised to the power of 3 over 3. You already know the general formula for the such integral. If you have integral of x raised to the power of n dx, that will just be x raised to the power of n plus 1, everything over n plus 1 plus your constant c. Okay, that's what we're going to do here also. So that will be 1 over pi. That one is still constant, is out. So 1 over pi. Then, if we integrate x raised to the power of 2, we're just going to get x raised to the power of 3 over 3. So that's what we're going to get there. So x raised to the power of 3 over 3. Then don't forget the limit is from minus pi to pi. That one is very essential. From minus pi to pi. Okay, now since we have this, so if you apply your limit, so what we are going to get for our a naught, so that will be 2 pi squared everything over 3. That's what we are going to get for our a naught if we simplify completely. All right, so we're going to have 2 pi squared, then everything over 3. So that's our a naught. So we already have the value for our a naught. Okay, so we are moving gradually. So the next thing to solve is solve our a n. You already give us the formula for calculating a n. Okay, so I said a n now is equal to 1 over L. It's very important to know those identities. So 1 over L. So integral. So the integral is also running from A to B. All right. Then f of x. No, f of x, that, but here we are going to have what cos nx dx. So f of x cos nx dx, and then our L is pi, a is minus pi, b is pi, and then our f of x is x squared. That one is very important. Okay, all right, so let's move on. Just going to have 1 over pi, okay, then integral from, sorry, this is b, sorry, so this is b, okay, so that's from minus pi to pi minus pi to pi. Then our f of x is x squared cos nx dx. All right, so here if you use integration by parts, don't worry, in my next video I will explain this integration by parts using this particular question here. So if we use integration by parts, so what we are going to have will just be, so I write the solution down because of our time. I'm going to write the solution, what we are going to get. So that's 1 over pi, 1 over pi. Okay, so if we integrate x squared cos nx, so we use integration by parts. So this is what we are going to have. So we're going to have x squared over n, x squared over n, okay, multiply by sine nx, by sine nx minus minus 2x over n squared, minus 2x over n squared, okay, then multiply by cos nx, sorry, plus will be here, plus will be there, okay, so multiply by cos nx, cos nx, okay, then minus 2 over n raised to the power of 3, minus 2 over n raised to the power of 3. So multiply by sine nx, multiply by sine nx. So the limit is also from minus pi to pi. Don't forget, from minus pi to pi. All right, so if we apply the limit, so we are going to have this as our answer. So we are going to have an is equal 1 over pi, 1 over pi, then multiply by, that would be 4 pi over n squared, 4 pi over n squared, pi over n squared, then multiply by minus 1 raised to the power of n, multiply by minus 1 raised to the power of n. So that's what we're going to have. There is pi outside and there is pi inside the bracket, so the pi can cancel out. So if the pi cancel out, so what we are going to have will be 4 over n squared multiplied by minus 1 raised to the power of n. So that's what we are going to get. Okay, multiply by minus 1 raised to the power of n. So then that's the answer to our an. So the next thing, or our next step, is to find the value of bn, that is what bn will be. Okay, so finding bn, using the formula I gave the other time, I said bn is equal to 1 over L. So bn is equal to 1 over L. The integral is also running from it's running from a to b. It's running from a to b. Then we're going to have f of x sine nx dx. Okay, so this will just be 1 over pi. Okay, 1 over pi, then integral, the integral will be from minus pi to pi. From minus pi to pi, that's the limit of the integral. Then our f of x is not changing, which is x raised to the power of 2, then multiplied by sine n x dx. So using integration by part also, yeah, we're going to have, I will write down the answer straightforward. So that will be 1 over pi multiply by, so this will be the result you get if we integrate that. So we are going to get minus x over n minus x over n. Sorry, I wrote b instead of n. Okay, so we have minus x over n, then multiply by, with it, minus x squared, rather minus x squared. Very sorry, it's because of my keyboard. Sorry, minus x squared over n. So multiply by cos x, multiply by cos n x. Okay, then minus 2x over n squared, minus 2x over n squared, minus 2x over n squared, then multiply by sine nx, multiply by sine nx. All right, then plus the final part, which is 2 over n raised to the power of 3. 2 over n raised to the power of 3. Okay, raised to the power of 3 multiplied by cos nx, multiply by cos nx. So then if we apply our limit, the limit is running from minus pi to pi. It's running from minus pi to pi. All right, if we compute the limit, if we apply our limit, what we are going to get is 0. Okay, so bn will be equal to 0. Bn is equal to 0. All right, so we've gotten the value of a naught, we've gotten the value of an, we also gotten the value, we have also gotten the value of bn. So we cannot find the Fourier series, we can obtain the Fourier series for the given function. So don't forget the formula for the Fourier series, which is a naught over 2. So f of x is equal to a naught over 2, a naught over 2, then plus summation, the sum of an, summation of an multiplied by cos nx, multiplied by cos nx, then plus bn multiplied by sine nx, multiplied by sine nx. Don't forget the limits of this summation is from 1 to infinity. Okay, don't forget that it's from 1 to infinity and running from 1 to infinity. All right, so since we already are ready, so we can now input all the values that we solved for. So then we have f of x is equal to, a naught is 2 pi squared. over 3. So we can now write this as um 2 pi squared over 6, 2 pi squared over 6. All right, so 2 pi squared over 6 plus, so the summation, your summation is starting from 1 to infinity. So from 1 to infinity of, so the value of an, so the value of an is 4 over n squared multiplied by minus 1 raised to the power of n. Okay, so and then everything over n squared. All right, so I'm going to have 4 multiplied by minus 1 raised to the power of n over n squared. Then don't forget the summation is starting from 1 to infinity. Okay, starting from 1 to infinity. All right, then plus, don't forget our cos. Cos nx is there, so multiply by cos nx, and we already know that bn is 0. So if you use bn to multiply sin nx, everything will be 0. So this is just, we are left with. All right, and then you can see 2 pi squared over 6. So this can also be written as a f of x will now be equal to, 2 into that's 1, 2 in 6, that's 3. So we're going to have pi squared over 3, pi squared over 3. Okay, plus summation of n, summation of n running from 1 to infinity of n squared, 4 multiplied by minus 1 raised to the power of n over n squared, then multiply by cos nx. All right, so the limit is from 1 to infinity. 1 to infinity. All right, so that's the obtained series. So we've obtained a Fourier series for the given function. But the main work you want to do here is to deduce that summation of n from 1 to infinity of 1 over n raised to the power of 4 is equal to pi raised to the power of 4 over 90. All right, yeah, this is what we are going to use. So we are going to use the Perseval identity. So using the Perseval identity, using Perseval identity, and here is the identity. If you have integral of f of x, integral of f of x raised to the power of 2 dx, okay, and then the summation is from minus pi, the integral is from minus pi to pi. So this is going to result to pi multiplied by a naught squared, a naught squared over 2 plus summation of a n squared, summation of a n squared. So this summation is starting from 1 to infinity. So from 1 to infinity. So that is where the summation is starting from. So from 1 to infinity plus summation of bn squared from 1 to infinity also. Summation from 1 to infinity of bn squared, bn squared. Okay, All right, so we already know the value of a naught, a n, and b n. So we can just substitute those values into that identity. So substituting those values into the identity, so I'm going to have, don't forget our function f of x is cx squared. Okay, so that would be x squared raised to the power of 2. So that would be x raised to the power of 4. So we have x raised to the power of 4 dx. Don't forget the limit is from minus pi to positive pi. It's from minus pi to positive pi. All right, so this will be equal to, so applying those are limits, so that will be pi, those values given or that we have calculated from the previous one, that will be pi multiplied by, a naught is 2 pi squared over 3. So that will be, a naught is pi squared. What's the value of a naught from our solution? A naught is 2 pi squared over 3. So that's the value of a naught. So that will be 2 pi squared over 3 squared. 2 pi squared over 3. 2 pi squared over 3. So everything squared, don't forget, all over 2 plus summation of an. Don't forget the value of an is 4 over n squared multiplied by minus 1 raised to the power of n. So then if we square that, so we're going to have 4 multiplied by minus 1 raised to the power of n, minus 1 raised to the power of n over n. So don't forget to square it. So squared. Don't forget our summation is from 1 to infinity. 1 to infinity. All right, so we already know that bn is 0, so we don't need to take the summation. All right, so 0 squared will just give us 0, so we can neglect our bn. So just focus on the remaining one. All right, so if we simplify this further, we're just going to have integral from minus pi to pi of x raised to the power of 4 dx. Integral from minus pi to pi of x raised to the power of 4 dx. Okay, this is just going to give us, if we simplify the right hand side, so that will be pi multiplied by, so we're going to have 4 pi squared over 18, 4 pi squared over 18 plus 16 multiplied by the summation of 1 over n raised to the power of 4. Summation of 1 over n raised to the power of 4. Then the summation is starting from 1 to infinity. It's starting from 1 to infinity. Okay, so we have this now. So if we integrate x raised to the power of 4, so we're just going to get x raised to the power of 5 over 5. So x raised to the power of 5 over 5. Then applying the limit, the limit is from minus pi to pi. So applying the limit from minus pi to pi. Is equal to pi multiply by, so if you simplify that, 4 pi squared over 18, so that's just going to give us 2 pi raised to the power of 5. I mean, it's going to give us 2 pi squared over 9. So that's what it's going to give us there. Oh, sorry, it's 2 pi raised to the power of 4. That's what it's going to give us here, not 2 pi squared. That was a mistake. So that's 2 pi raised to the power of 4. So we're going to have 2 pi raised to the power of 4 over 9. So that's what you're going to get here. So plus 16 multiplied by the summation. So the summation of 1 over n raised to the power of 4 over 1 over n raised to the power of 4. So the sum is starting from 1 to infinity. Starting from 1 to infinity. Okay, so we have this now. Okay, so if we simplify our left hand side very well, so what we are going to get is 2 pi raised to the power of 5 over 5. We're going to get 2 pi raised to the power of 5 over 5. That's what we're going to get. Okay, 2 pi over 5, raised to the power of 5. So that's what we're going to get. It's equal to, then if we open the bracket of our right hand side, so we are going to have 2 pi raised to the power of 5 2 pi raised to the power of 5 2 pi raised to the power of 5. Okay, over 9, then plus 16 pi summation of 1 over n raised to the power of 4, n raised to the power of 4. Then don't forget the limit is starting from 1 to infinity. So from 1 to infinity, that is where the limit is starting from, and that is when it's end. All right, so we can actually collect like terms. That is, we have 2 pi raised to the power of 5 over 5 and 2 pi raised to the power of 5 over 9. We can bring them together. So I'm going to have 16 pi multiplied by the summation of 1 over n raised to the power of 4 over n raised to the power of 4. Okay, the summation is starting from 1 to infinity. So n is starting from 1 to infinity. So everything will just be equal to 8 pi raised to the power of 5 over 45. If we bring 2 pi raised to the power of 5 over 5 and 2 pi raised to the power of 5 over 9 together, so that's what we're going to get. So we're going to get 8 pi raised to the power of 5 over 45. So that's what we're going to get. Okay, so next step, so dividing both sides by 16 pi. So we divide both sides by 16 pi. So we are going to have summation of 1 over n raised to the power of 4. So then running from 1 to infinity. Running from 1 to infinity. So n is from 1 to infinity. So this is just going to be equal to, we have 8 pi raised to the power of 5 over 45, then divided by 16 pi. So we are going to have pi raised to the power of 4 over 90. Pi raised to the power of 4 over 90. So that's what we're going to have. So we've deduced uh, the value for the summation of 1 over n raised to power 4 from 1 to infinity. So please don't forget to subscribe to my channel, share my videos, comment, and like. Thank you all. God bless you.